Hello, my dear 10th standard children. Welcome to lecture number 13 on light, reflection, and refraction. In the last class, we studied these points. Number one, the phenomenon of change in the path of light as it travels from one medium to other medium is called as refraction of light. As we were discussing the concept of refraction of light, where we defined the phenomenon of refraction as it is the change in the path of the light as it travels from one medium to another medium. We also came across optical medium. It is the medium through which light passes. We call the medium as rarer when the speed of light is entering into the medium. Better, the light which is moving with some speed and entering into the medium is more, then we call it as a rarer medium. If the speed is less, then that is called as a denser medium. Okay. We also came across interface or boundary. It is the space or region that separates denser and rarer media. The incident ray of light, the ray of light which is falling on the refracting surface is taken as incident ray of light, or simply incident ray you may call. Refracted ray, the ray of light which passes through refracting surface. Normal is the point at which both incident and refracted rays of light meet. That point is taken as normal. The angle between incident ray and normal drawn is called angle of incidence. Similarly, the angle between normal drawn and refracted ray is taken as angle of refraction. So, angle of incidence is the angle between incident and normal drawn, and the angle between normal and refracted ray is taken as angle of refraction. Note that for refraction of light, dear students, medium should be transparent. Medium should be transparent. So for refraction phenomena, medium should be transparent, which is like glass slab or water in a container, like that. You need the medium should be transparent. Okay. And also the densities are different. Generally, rarer medium is different, denser medium different, which means the densities of media differ from one medium to another. So that is the second point. Okay. Densities are different for different media. So these are the points which I have discussed in the last class, except this note part. So for refraction of light, you must take into consideration the medium should be transparent and densities of media are different. Okay. Let us add some more explanation into the phenomenon. As we know, changing the path of light or light ray you may call, as we know, change in path of light which is traveling from one transparent medium, better word will be one transparent medium to another transparent medium. That phenomenon is taken as refraction of light. So refraction of light is change in the path of light, change in the path of light as it is traveling from one transparent medium to another transparent medium. So the transparent media should be either rarer or denser. So transparent media should be rarer medium or denser medium. Okay. So here we have a diagram. One, here they have mentioned substance, you better call it as medium number 1, and substance 2 as medium number 2. So medium 1 we can consider air, and hence it is a rarer medium, and medium 2 should be water, that is denser medium in comparison with air. Okay, so how do you get this phenomenon? As the ray traveling from one transparent medium to another. Air is one transparent medium, water is the another transparent medium. As it is traveling from one medium to another, it changes its path. So this is the incident ray which is here, which is falling on interface or refracting surface. From that point onwards, it bends like this. It bends like this. So this phenomenon is taken as refraction of light. Okay. So one more point you can add. This is the normal drawn. With respect to this normal, bending or change in path occurs. Okay. Now you can give two more points here. When the ray of light traveling from rarer to denser medium, from air to water you may call. Okay, when the ray of light traveling from rarer to denser medium or air to water, the angle of incidence I is greater than angle of refraction R. So when the ray traveling from rarer to denser, from air to water or from air to glass, okay, angle of incidence is greater than angle of refraction. And similarly, when the ray of light is traveling from denser to rarer medium, it is less. So angle of incidence I, which is less than angle of refraction R. Let us take to the diagram here. So when the ray of light is traveling from rarer to denser, from air to water, so angle of incidence I, this is I greater than angle of refraction R. So with respect to normal, I is greater than R as it is traveling from air to water or rarer to denser medium. Okay. And on the other hand, if the ray of light is coming from denser medium to rarer, then you can say that angle of incidence I is less than angle of refraction R. I hope you got these points right. Now let us take the cause for refraction of light. So what will be the cause for the phenomenon of refraction? If you are asking, answer lies here. When the light ray is passing from one medium to another, you may call light ray or beam of light, whatever. When the light or light beam or light ray is traveling from one transparent medium to another transparent medium, the speed at which it is moving changes, which causes the refraction. Remember, change in the speed of light means they are not drastic. They are just minute changes, not the 100%. As we know that light is traveling from, the speed of light in vacuum is 3 into 10 to the power 8 meter per second. This is a relatively high number. Keep in mind, this is very much high number. So it doesn't mean that it should change so much, say 1 into 10 to the power 8, not like that. It is just into 10 to the power 8 only, just minute changes in this section. Okay, so keep in mind, change is a change. Okay, so when the light ray traveling from one medium to another, it changes its speed. Since the change of speed occurs, that causes the refraction of light. I hope you got this point clear. Here I missed a point. I said I is greater than R when the light ray is traveling from rarer to denser medium. I greater than R means what? I greater than R means the angle of incidence is greater than the angle of refraction. Keep in mind, when the ray of light is moving from one medium to another, with respect to normal, it deviates towards normal. It deviates towards normal. I greater than R means the incident ray of light which deviate towards the normal, which means this is the refracted ray which is closer to the normal. Okay, and in the second case, I less than R means when the ray of light traveling from denser medium to rarer medium, it bends away from the normal. It bends away from the normal. It is moving away from the normal. Exactly the reverse picture you can draw momentarily as. So this is the interface. Assume this is the normal. The light ray which is entering from denser medium this time, denser medium to rarer medium. Okay, so after passing the interface, it bends away from the normal like this. Okay, so this is normal. This is the first will be, this is taken as incident here as it is in the denser case. So as the light traveling from denser medium to rarer medium, it bends away from the normal. No, look at this picture. You will get this refracted ray which is moving away from the normal. In case of previous, that is when the light is traveling from rarer to denser medium like this, it bends towards the normal. It bends toward the normal. So it is appeared to be close, and hence in this case is I greater than R. In the second case, I is less than R. I hope you are getting these things right. Now let us take the same refraction phenomena through a glass slab. So we are considering this phenomenon in glass slab, how refraction occurs in the glass slab. So this is the glass slab. Okay, so a laser beam, you better say take it as ray from laser source is taken. So it is moving like this. Here you are getting the bending, yet again you are getting the bending over here. So this is the original picture, and on the other hand we have the diagrammatic sketch. Okay, so first we need to understand, as I said earlier, when the ray is entering from rarer to denser medium, it move towards the normal, and as it is from denser to rarer medium, it moves away. Okay, for that we have made a little adjustments here. We took the rectangular glass slab A, B, C, D, and we have air medium, glass medium, and air medium again, glass slab. Therefore, you can get air glass, air media. Okay, so this is the incident ray of light. This is the incident ray of light which is falling on the first interface. I will call it as first interface I, and this is the second interface I. You better call it as I1, I2. Interface number 1, that is air glass boundary. I2, glass air boundary. Okay, so this is the incident ray of light. We drawn the normal N1, N2, and we are continuing the same because light is still traveling inside this. So M1, M2 be the another normal. So N1, N2 for the incident ray of light, that is the normal drawn, and M1, M2 again, that is the normal for the second case, that is from denser to rarer medium. Okay, so the angle between incident ray I, incident ray I, that is the ray which is falling on the normal and which is creating the angle of incidence I, and after hitting the interface, the light bend towards the normal. Light bend towards the normal means it is closer to normal N1 and N2. Okay, and on the other hand, this process will continue after passing from air to glass media. What happens? The ray which deviate towards the ray of light deviates toward the normal and which is continuing. Okay, so this will be the refracted ray. Actually, this is the refracted ray. In this second case, this becomes incident ray as it is traveling from denser to rarer now, as it is traveling from denser to rarer medium. So this R is taken as I also, no problem. So better you take it as R as it is. So the light ray which is now passing from denser medium to rarer medium. Denser medium to rarer medium means glass to air. Now what to do? M1, M2 is the normal this time. What happens? The light should move away. As I said, when the ray of light which is passing from rarer to denser medium, it bend towards the normal. As it is passing from denser to rarer medium, it is moving away from the normal. Okay, so after hitting the interface 2, it moves away from the normal and the light is emerging out of the glass slab. So this is called as emergent ray of light. So first one will be the incident ray of light, second is refracted ray of light, and that refracted ray will be the incident for the second case, and the overall, that is the third part, that is light is coming out of the glass slab, which means that is taken as emergent ray of light. So you can note that if no glass slab, what happens? The light should go like this. It is shown by the dotted lines over here. So light should go pass through if no glass or glass slab, it should go in this direction as shown in the dotted line here, and when you bring the glass slab in between, what happens? It deviates twice. Okay, so refraction occurs once here and refraction occurs twice here. One is towards the normal and one is the moving away from the normal. If you compare with the dotted lines with this, you will get parallel to each other. So if you are comparing, they are parallel to each other. You can compare this and this two, no problem, they are parallel. Better you compare here only. So in doing, the light gets refracted twice as it is traveling from glass slab. So from the glass slab, the light refracts twice. So this is about refraction of light through glass slab is concerned. I hope you got all these points correctly. I'm going to stop at this point of time with new concepts of this topic. I will meet you once again. Till then, take care of yourselves. Bye bye.